Consider a population where 1% of the individuals display the recessive phenotype. Given that the frequency of the recessive phenotype in a Hardy-Weinberg equilibrium is equivalent to Q squared, in a population where 1% possess the recessive phenotype, Q squared, the frequency of the Q allele would be 0.1. Since P plus Q equals 1, or 100% of the alleles of a population, when Q equals 0.1, the frequency of the P allele is 0.9. In a population where 90% of the sperma and ova possess the dominant P allele, and 10% of the sperm and ova possess the recessive Q allele, one can calculate the frequencies of the P homozygotes, the heterozygotes, and the Q homozygotes. Note that the sum of all of these categories, the P homozygotes, the heterozygotes, and the Q homozygotes, equals 1, 100% of the individuals of the population. Just as P plus Q equals 1, the sum of these two allele frequencies equals 100% of the alleles of the population.